In this paper, I'm trying to present an approach to use reified input-output logic to use it for compliance checking via SHACL. And actually, this is only the tail of a research endeavor that I'm carrying out since more than 5 years. I started at the University of Luxembourg in order to combine natural language semantic, deontic logic, artificial intelligence law, and OWL RDF. And my plan is to use reification as the main formal instruments in order to glue all together, to use them all together, because all these 4 topics has been investigated in different research. What I would like to do is to carry out all together, to keep a fit in every strand. And on the wake of the transition from machine learning to symbolic approaches for AI, this is you know that explainer artificial AI is becoming very popular nowadays. So this is my contribution to the field, and in particular in the field of artificial intelligence and law. And reification, as many of you know, is a philosophical concept that was firstly introduced by Donald Davidson, who was a philosopher and in natural language semantics, and is a technique that consists in transforming something that is abstract, like a relation, a predicate, into something that is concrete. So basically, we associate predicates with constants or variable in first-order logic on which we can assert other predicates. And reification is a very popular technique, so that nowadays there are several hundreds of neo-Davidsonian approaches to natural language semantics. And the one that I adopt is the one authored by the professor in the middle of this picture, that is Professor Jerry Hobbs, that his theory is a theory of natural language semantics is grounded on a massive use of this reification technique. And so, for instance, in Hobbs logic, we flat everything, and that's the magic word is flat. We transform everything into a flat conjunction of atomic predication. So even if a sentence, John knows that he cannot fly, that in standard logic can be represented with something like this, in which we encapsulate the operator, the model, and the Boolean operators within one another. In Hobbs is all flattened in a formula like this that reads, it really exists an event on knowing that is performed by John, and in particular John knows this other event. This is the fact that something else is not existing. This something else is the fact that John is doing a certain action. This action is the fact that John flies. So this is how we read this formula. And as you can see, we reify even the Boolean connected. So the only, this is first order logic, but actually is a fragment of a very limited fragment of first order logic, in which the only Boolean operator is the conjunction. And then on parallel, you know that there are several approaches to deontic logic, and in particular there are approaches that are called norm-based, that try to model deontic logic in terms of if-then rules that state that if something exists, then something else is obligatory or permitted, or something else is entailed, so we have a constitutive rule. And the most popular norm-based deontic logic is this input-output logic, authored by my supervisor in Luxembourg and David Mackinson, and so that input-output logic is basically represent deontic rules in terms of flat set of if-then rules. And again, the magic word that suggests to integrate the two together. This is what I was working in Luxembourg, where I proposed this new logic, in which we basically combine the logic of Jerry Hobbs with input-output logic in order to move beyond the propositional level. level, because before that, input topology is only studied at the prepositional level, but this is not expressive enough to represent the natural language semantics. So my idea, let's use replace propositional logic with the logic of Jerry-Hofs, and use reification in order to flatten complex operator that in standard logical approach requires embedding of subformula within other operators. Here we flatten everything, and the idea is in this way that we can build a larger repository of norm from existing legislation which is available in natural language. And so here we have an example from the GDPR. This article that is basically stated that every personal data processing has to be lawful, and is formalized with respect to this if-then rule. This is an if-then rule in input topology, stating that for every personal data processing, so for every event that exists at time t1, and there is it is a personal data processing between X and Z, and X is a processor and Z is a personal data of the data subject W, then it is obligatory for this processing to be lawful. Okay, everything is formalized like this, and we reach the standard input topology with this first order reification based approach in order to model more easily natural language statement. And in particular, we want to do them quickly because legislation is huge. We have to build this repository quite in a short time. And this is what I did in another project at the University of Leipzig, in which I translated the whole GDPR in reified input topology together with Monica Palmiani. In this project, I worked with Monica Palmiani. In particular, she developed an ontology that is called Pronto for the GDPR, and then I used the concept of Pronto in order to model the norms in the GDPR. And if you are interested, the knowledge base is available on the GitHub and described in that journal paper. Now, coming back to this is what I did so far before this paper, but as you can see, there is a missing ingredient, in which is what I work in now. Because as also my dear friend Guido Governatori always has a kind of morbid pleasure to underline, is that reified input topology is a wonderful theory, but it's just a theory. So for now, we only use it to represent them on paper, but we cannot reason because no automatic reasoning currently exists, and it's right. So you can see also my disappointed face on the right. So that the idea is to transform everything, so the OPS logic to implement in RDF in OWL in order to use the reasoner that are already available for RDF and OWL, because also RDF models, again the magic word, into flat knowledge into flat sets of triples, so that there is a direct mapping between the logic of Jerry-Hofs into triples in RDF, and so for I guess you know that so this is the interface of Tobriad. We can take any statement in OWL in RDF, and we can reify with the interface, for instance, of O'Brien to represent, to introduce a new variable that, a new constant, sorry, that refer to the event, to the statement, for instance, here in this example, to the fact that in Italy, the minimal age for consent is 14. And in parallel, what I want to do is, besides formalizing Jerry-Hofs in RDF triples, then we have also to model the if-then rules, so to connect the antecedent with the consequent. And for that, I'm planning to use this SHACL, that is a new recommendation for W3C, that will allow me to implement these if-then rules, to implement both obligations and permission and other constitutive rules. And here here now this formula, of course, a bit complex. You can have a look in the paper, in which I extract a fragment of Pronto, and then I defined a kind of initial methodology in order to formalize some selected if the rules from the data knowledge base in this SHACL. And you can see, for instance, to check lawfulness, to implement the if-then rule, the reified input topology formula that I showed you before, we write this SHACL shape, in which it requires that if there is a personal data processing, this personal data processing must have the attribute is lawful as true. And this is not something that is asserted. So this is something that is checked. And if when a SHACL is executed, SHACL tell me that this ontology, in particular with respect to this individual, to this personal data processing, is not valid because it doesn't respect this shape. And this is the way in which we can implement obligations. Okay, because you know that obligations are not inconsistency. So the ontology can be consistent, but still we can have some violations, like if the value of this Boolean will be false. And here in an example on how we implement a constitutive rule, because here it says, here there is a rule that says that if there is if the data subject has given consent and there is not this exception, this exception, now I don't have the time to detail about that, but you find it described on this paper. The exception says that the data subject has not to be a minor. So it basically says if the data subject has given consent as in not a minor, then assert is lawful as true. And then if this constitutive rule triggers on the ontology, this Boolean is asserted as true, and then this obligation, of course, that is satisfied. So the ontology is validated with respect to the obligation modeled in terms of SHACL shapes. And this is what I'm working now. Any of you is very kindly invited to join me if is interested in SHACL, in reified input output logic, and that's all. Thank you very much.
Thank you, Mr. Livio Robaldo. We have a question. Firstly, I enjoyed explanation and the correlation of the compliance and the deontological reasoning. My question regards the given explanation of the deontological reasoning, as we faced the idea that compliance can take into consideration good practices, norms, which don't necessarily bind the parts. How we have to face this possibility when analyzing your model?
Yeah, this is exactly what I'm working now because in the slide I showed an example of exception that are hard-coded in the legislation. What I'm working now is to work on legal interpretations and argument of the several concepts, because okay, to check if a data subject is a minor, this is quantitative. You look in his ID, and if he's beyond a certain age, is not a minor, otherwise is a minor. But of course, there are many other concepts that can be subject to legal interpretation. So we can have, as is written, as is asking the question, someone that can have an opinion, and someone that can have a different opinion. Then it is up to the DPIA, to the Data Protection Authority, to take a decision in the case of the GDPR. In case of other norms, it will be a judge in the court. And what I'm doing now is to model legal interpretation in terms of other concepts and also arguments and all what we need in order to support a certain legal interpretation. And so that we can encode within the ontology also the good practice, the recommendation from the DPIA, and also including the decision. We can, when there is a conflict between norms, there is an authority that is summoned in order to take a decision about the conflict, and the decision is supported by argument. All these can be represented in terms of our concepts, and this is the way I would like to do, and so that you can have different form of reasoning according to the legal interpretation that you select. Then certain authorities will override other authorities, so the reasoning will be again deterministic. In case we have two authorities that state different conflicting opinions about the same, we will have a non-monotonic reasoning, but this is what happened in reality, and so is fair to model the same also within the ontology by the artificial intelligence.